Good morning student, myself Mili Sankla, and in today's session we again solve the example of consistent deformation method. Okay, now in this example today we solve another type of beam. This is our prop cantilever beam, but in this prop cantilever beam, this beam subjected to moment of inertia I and 2I. Okay, again this is a different type of beam, different type of data using the method of consistent deformation. Analysis the beam as shown in figure and draw the shear force and bending moment diagram where EI is equal to constant. Now my first step is equal to find out SI of beam. Right here our first step is equal to find out SI of beam. Now this is A point, this one is B point, C point, distance is given 3 meter. Okay, this distance is given 3 meter and this is roller support. Fix and roller. Our support reaction is 4 minus 3 is equal to 1. Okay. Now here this fixed beam, here this roller support is subjected support reaction VB. Okay, this is extra unknown force, we find out VB. Now in second step, this prop cantilever beam subjected 50 kN load. This distance is 3 meter, this distance is 3 meter, and release this VB, and this beam is converted into the statically determinate structure. Now next, again this cantilever beam subjected to load 50 kN. This distance is 3 meter and moment of inertia is equal to I. Here the distance is equal to 3 meter and moment of inertia I. Now due to this external load, beam is deflected this way. We release the support the redundant force, extra unknown force is B point, so we find out deflection is also B point, del B. Now find out bending moment, okay, due to external load. Here our first point is MB, second point is MC, and third point is MA. At MB our moment is equal to 0. At MC again our moment is equal to 0, and moment at A is equal to 50 into 3, and this is clockwise right hand side, minus 50 into 3 is equal to minus 150 kilonewton into meter. Now again make a free end to fix. This is our A point, this one is our C point, and this one is our B point. Now distance is given 3 meter, distance is given 3 meter. Okay, from this C point, B point moment 0, and moment of this A point is given 150. Okay, simply mention this is inclined because point load, minus all given number of forces are indicate as the upward direction, and this moment is 150 I. Here I is given 2I, so mention here 2EI, and my answer of this solution is 75 by EI, because moment of inertia from this C to A point is 2I, so divide by 2EI, and answer is 75 by EI. Okay, and this is our M by EI diagram due to external load, and this is our 50 kilonewton. Now for unit load turn, again make a remove all type of loading and apply 1 kilonewton load at a point of support reaction VB. Okay, next again due to this distance is given 6 meter now, and this distance is also 6 meter. Now due to this upward load, our beam is also deflect in upward direction. Okay, like this, and this deflection is known as del BB. But guys, this is our C point, this is our B point, and this one is A. Here moment of inertia I, and here moment of inertia 2I, and this distance is 3 meter and this distance is 3 meter. Now one by one we find out the moment here. Okay, and simultaneously draw the bending moment diagram. First of all we fix this free end to fix. Now from this 1 kilonewton, okay, from this point our distance is 3 meter and this distance is also 3 meter. Now moment at this C point 1 into 3, that means 3 by ER. Okay, moment at this point, make a point here. This is A point, this one is C point, and this one is B point. This is the moment of inertia I, and this point is moment of inertia our 2I. Now distance is equal to 1 into 3, that means 3 by EI. Okay, now from this point, just left hand side, our moment of inertia is 2I. That means from this junction point we have to half the moment of inertia, because some portion of beam is subjected to I and some portion of beam is subjected to 2I. Now to find out support reaction, to find out unknown forces, here we convert the moment of inertia of beam is constant, that means in some one perfect value, one value, that means this value is I and this value is 2I. If I want to convert this 2I into I divide this 2I by I. Okay, I want to convert this 2I into I. Simply what shall I do? I do 2I divide by 2, that means this 2I is converted into the I. Ultimate my whole cantilever beam is converted into the moment of inertia I. Okay, now we have to make a half of value from this junction point. That means from this point my value half is equal to 1.5 by EI. Okay, and now here from C to A our distance is given 3, that means this height is also 3 by EI. Ultimately this is 1 into 6 by A, but that is the portion of 2I, so we have to make a half, that is 3 by A. 6 by A is equal to 3 by A, and this is point load, so make like this way incline. Okay, now here this portion is formed in trapezium, so again we convert into triangle and rectangle. This total height is equal to 3 by EI, and this top height, because this total is 3, but this half is 1.5, so mention here this is 1.5 by EI, and this height is also 1.5 by EI, and this is our plus diagram, so forces are indicate in down direction. Okay, and this diagram, this is our M by EI diagram due to unit load. Okay, this diagram is due to unit load. Now we find out deflection due to external load and deflection due to unit load. First of all, make a heading here. Okay, now we find out our del B, and this del B is due to deflection due to external load. Okay, now make a heading here. First we write down deflection due to del B is equal to deflection due to, make a heading, deflection due to external load. Okay, now for external load we follow this diagram. Okay, here in this diagram, first of all make a sinus minus, and 1/2 area is equal to 1/2 into 3 into height is equal to 75 by EI into CG, 3 plus 2/3 into 3, right here 3 plus 2/3 into 3, and my answer of this del B is equal to 562.5 by EI. Now next we find out del BB, right here del BB is equal to deflection due to right here deflection due to our unit load. Okay, and this is equal to, this diagram here given 3 value. First of all, this is all our positive diagram. First add on this diagram 1/2 into 3 by EI, and CG is equal to 2/3 into 3. Write down 1/2 into 3 into 3 by EI, and CG from this point is equal to 2/3 into 3. Now plus this second diagram is equal to 3 into 1.5 by EI, and CG from this point 3 plus 1.5 by 2. Okay, right here This is 3 into 1.5 by EI, and CG is equal to, make CG is equal to 3 plus 3 by 2. Now last is third diagram, 1/2 into distance 3 and 1.5 by EI, right here 1/2 into 3 into our distance, height 1.5 by EI, and again CG 3 plus 2/3 into 3. Okay, because figure is 3 meter away, 3 plus 2/3 into 3, and my answer of this del BB is equal to 40.5 divided by EI. Okay, now next we find out our support reaction VB, and what is the equation of VB? Right here VB is equal to minus del BB divided by del BB, and del BB we find out minus 560.5 by EI divided by this 40.5 by EI, and this is equal to 13.88. Now we find out our second support reaction, that is VA. VA is equal to our total vertical load minus our support reaction VB. Okay, now total vertical load is equal to 50. Write down 50 minus our support reaction that we recently find out 13.88 is equal to VA, we find out 36.12 kilonewton, that is in upward direction. Okay, now first of all we draw the SF diagram, then we draw BM diagram. Here we find out our support reaction 36.12, and this is our second support reaction 13.88. This diagram is subjected to point load, and SF diagram of point load is in form of box. Okay, A point, this is our B point, and this one is the center point C. Now left hand side up for 36.12, make height this vertical line, and this is 36.12, and go constant up to the 3 meter distance from this point. 36.12 minus 50, and my answer is minus 13.88. Okay, use calculator and minus subtract this value, and answer is minus 13.88. Okay, this is our point 36.12 and 13.88. Okay, this distance is 3 meter, this distance is 3 meter, and this diagram is our SFD diagram. Now here we make a bending moment calculation, right here bending moment calculation. Now my first I here find out all bending moment from right hand side. Okay, now my first bending moment is MB, my second bending moment is MC, and my third bending moment is equal to MA. Now what is MB? MB is equal to 0. Okay, and MC is equal to this anti-clockwise and plus 13.88 into 3, right here 13.88 into 3, and my answer of this MC is equal to, okay, next we find out our MA. Just we find MA is equal to, moment is given here, my MA is equal to 13 point, right here this 13.88 into 6, because right hand side anti-clockwise positive, 13.88 into 6, and this moment is clockwise, minus 50 into 3, and my moment at A here 66.72 kilonewton into meter, and this answer is positive 41.64 kilonewton into meter. Okay, now one by one make a point here. This is A point, and this one is C point, and this one is B point. This distance is 3 meter, this distance is 3 meter. Now mark the point. at A point our moment is negative, okay, minus. So point mark below the reference line, that is 66.72, and this beam is subjective to point load, so beam diagram is inclined. So first of all draw this vertical line 66.72, and at C point we get positive bending moment, that is 41.64. okay, simply draw this inclined line, and from this C point to B point our moment is 0. Complete this diagram, and this value is positive, this value is negative, okay, and this is our bending moment diagram. Okay, now in next session we solve the last example of consistent deformation method. Okay, and again this example is for overhanging beam, but some rules are different there, that I will explain you at time of example. Okay, just now we stop here.